capital Fx in this way: F1, F2, F3 transpose. Okay, so I'll be able to substitute the values that I'll be given. Okay, so first of all, let's find the Jacobian matrix. So let me take you to the previous board. So we need to differentiate this F1. We need to find partial derivatives with respect to x1, x2, and x3. So similar thing will be done here and even here, the last equation. Okay, and that will be able to give us the Jacobian matrix. So in this case, the Jacobian matrix will be given by partial of f1 with respect to x1, partial of f1 with respect to x2, and partial of f1 with respect to x3. And then we'll move on to f2. So partial of f2 with respect to x1, partial of f2 with respect to x2, and lastly, partial of f2 with respect to x3. And the last row here will contain partial derivatives of f3. So partial of f3 with respect to x1, partial of f3 with respect to x2, and lastly, partial of f3 with respect to x3. So we'll just find this. I hope the space we have here will be enough. I'll try to squeeze my values. So we differentiate f1 with respect to x1, and I'll be able to see that in this case, it will just give me these three. Okay. So this side, I'm going to have 3. Then if I differentiate the same function with respect to x2, I'm able to see that I'm going to have a negative outside and there will be x3. Okay, then I differentiate cosine, it gives me sine. So it will give me sine, negative sine actually, negative sine. So let me write it nicely here. Negative sine x2, x3. So that's what we are going to get. If I differentiate it with respect to x3, then I'm going to have x2 here, and then the expression inside the bracket there will be the same. So that's what I'm going to get, and it will give me, So that will give me these values that I'm looking for. So it will be x3, then sine. I hope these values will be able to fit here. Let me wrap this, and I'll write my 3 here, and then I'll have x3 sine x2 x3. Then the last value will be, I think the space won't be enough. Let me write on the next board, but I'll just be following those partial derivatives in J. So J in this case will be equal to 3. Then the next value will be x3 sine x2 x3. And then lastly, I'll have x2 sine x2 x3, right? And then I'll move on to f2. I'll differentiate f2 with respect to x1, x2, and x3. So with respect to x1, I can see that this will just give me 2x1. Okay, so this will just give me 2x1. When I differentiate with respect to x2, if I look at this function, then this and that will be zeros. So I'll just get 2 times negative 81, then open bracket x2 plus 0.1. So that's what I'm going to get here. So 2 times 81, I guess you'll be able to get negative 162, then x2 plus 0.1. And then I differentiate this same function with respect to x3. So these others will be zeros. I'll just remain with the derivative of sine x3, and this will give me cos x3. Then I will do the same to the last equation, which is f3. So I would be differentiating, I would be finding those partial derivatives of f3 with respect to x1, x2, and x3. So looking at this expression, if I differentiate with respect to x1, I will have minus x2, then e to power minus x1, x2. Okay, so this will just give me minus x2, then e to power minus x1, x2. Then here I'm going to have minus x1, then e to power minus x1, x2. And then let me differentiate it with respect to x3. So I will just be differentiating that expression. So it will just give me 20. So I'm going to have a 20 here. So this is the Jacobian matrix. And I know the function f. So now I can just substitute the initial point that I've been given. So now you can evaluate j over x0. Okay. So it means where there's x1, x2, and x3, I'll be substituting 0.1, 0.1, and negative 0.1. Okay. So I think it's something that you can easily do. You can use your calculators now to verify that it will just give you these values. 3 and then 0.000, then 999, another 9, then 8, 3, 3, 3, 3, 4. And then you're going to have this same value again. 0.0099998333334. Okay. Of course, if you want, we can round it off to maybe 1 decimal place or something like that, or 3 decimal places. But in this case, let's take the values the way they are. So for at the far end here, then here I'm going to get 0.2, then here negative 32.4. So please verify these values that I got. I was just getting my values the way they were appearing on my calculator. So I'm going to get 950041653. Then here I'm going to have negative point or negative 0.99004983337. The same value will appear here, negative 0.99004983337. And lastly, I have 20. So this will be J of 0. And then we'll do the same thing to evaluate F0. So let me do it on the next board. So remember, Fx is given by F1, F2, and F3 transpose. So I'll just substitute those values in there, the ones that have been given. So I can now find F0. So let me wrap this part and use the initial approximation. Okay. So if you do that, you'll be able to get these values. So you'll just be substituting the values of x1, x2, and x3 in that initial approximation, and it should be able to give you this value, to give you negative 0.199995. Then the next value will be negative 2.269833,417. And lastly, 8.462025,346. Okay. So like I mentioned, we can avoid writing these long numbers by rounding it off to a given number of digits. But in this case, let's take them the way they are. Okay. So using this, I can, if I want, I can now find the inverse of this Jacobian matrix. Not that one, sorry. this Jacobian matrix we evaluated at x naught. So if you want, we can find the inverse of this. So it's a 3 by 3 matrix. Okay. If you don't want to do that, then it will lead you to a system of linear equations, like I mentioned earlier on. Okay. So if you don't want to do this, you can now let capital Y0 be equal to what? Y1, 0 if you want, Y2, 0, and Y3, 0 transpose. And then you'll be able to evaluate this. Remember we said y should be equal to minus f. Of course, we are evaluating this at x naught. Okay, so you'll be able to evaluate this. So if you do that, you are going to get a system of linear equations. I've been warned, ladies and gentlemen, that after 10 minutes, this meeting will end. I hope we'll be able to finish this example in 10 minutes. Okay, so it will be like multiplying this j by y. So I'm multiplying this by y equal to the negative of f, right? So I'll just get a system of equations from here. A system of linear equations. So what will that system be? So I'm going to, if I want, I can even write it in form of an augmented matrix. But first of all, let me write the matrix the way it will appear. I mean the system of linear equations, the way it's going to appear. And so it will just be y1, 3y1 plus that value 0.00099999, then 8333 y2. Of course, if you want, you can even say y2 0 here or y1 0. Okay, you can do that, and then the other expression you're going to get will be the same value, 0.00099999, then 833334 y3, and this will be equal to the negative of f. So the negative of f, so this will be equal to the first value there, which will be multiplied by a negative. So it will now be 0.199995, right? You're going to do the same thing to the second row. So it will be 0. So it will give you now 0.2y1. Okay, so I'm using this matrix J here. So it will be 0.02y1 minus 32.4y2, then plus this value y3 equal to the negative of f. Okay, so I'm going to have a negative 32.4y2, then plus 0.9950041,653 y3, and this should be equal to the negative of that value. So it will be 2.269833417. And lastly, I'm going to get negative 0.9900498337y1, then minus 0.9900498337y2, then plus 20y3, and this should be equal to the negative of this value. So it will be negative 8.4620. I guess that's 2 that I wrote there. 2025346, right? So we now have a linear system of three equations in 3 unknowns. So you can now use the direct method. You remember we talked about direct methods for solving linear systems of equations. So you can do that. And then after solving this system, you should be able to get y0 now, which will be equal to y1 0, y2 0, and y3 0. And if you do that, it should be able to give you this value or these values. Please verify that you'll be able to get these values. I think let me write them down here. So you're going to get 0.49986. Okay. No, 0.3998696,728. Then the next value will be negative 0.08533155147. And lastly, negative 0.42152 then 4718 transpose. Okay, so after doing this, now I can go to this equation. Xk is equal to xk minus 1 plus yk minus 1. So in this case, it will be x1, the first approximation, to be x0 plus y0. So x0 is the column vector that I've been given, and then I can just add these two. So adding them should be able to give us this solution, 0.4998696,728. Then the next value will be 0.01946684853, and the last value will be negative 0.5215204718 transpose, and that will be the first approximation.